Hello students, welcome to SQL tutorial for beginners. This is part 2 of Database Management System and Database Design course. In the last video, database concepts and database normalization were discussed. In this video, SQL or structured query language concepts are explained. This video is for beginners to help them understand the important concepts related to SQL language. SQL concepts are explained with examples. What is SQL? SQL stands for Structured Query Language. SQL is structured query language to manipulate data in relational databases. It is standardized by ANSI or American National Standards Institute. It is implemented by every relational database management system. Every DBMS vendor aims to comply with these standards, causing the various similar implementations of SQL. However, each implementation provides a unique dialect or SQL extension or additions to the standard language. For example, SQL Server provides TSQL and Oracle provides PLSQL, which are superset of standard SQL. SQL is non-procedural language. It means you only need to specify what to do. It figures out how to do or how to perform the job. In simple words, you can perform data manipulation operations without knowing how data is stored internally in the database or how the operation will be performed. Managers and database administrators can use SQL to produce useful information without knowing a high-level programming language. SQL is based on relational algebra and relational calculus. If you understand the relational operations, you can easily write SQL statements to manipulate relational databases. Let us see some major properties of relational algebra. Relational algebra operations are performed on one or more tables or relations. The output produced is another relation, leaving the original relations intact. It means input for any relational algebra operation can be one or more relations, and the output would be another relation, but the original participating relations will remain unchanged or intact. Both operands and results are relations, so output from one operation can become input to another operation. It means that both the input and the output are relations, so they can be used iteratively in different requirements. Relational algebra allows expressions to be nested, just as in arithmetic. This property is called closure. There are 5 basic operations in relational algebra. These are selection, projection, Cartesian product, union, and set difference. These operations are used to perform most of the data retrieval or query operations. There are some other operations like joins, intersection, and division, which can be expressed in terms of 5 basic operations. There are 2 types of relational operations, unary operations and binary operations. Unary operations are performed on a single relation or table, whereas binary operations are performed on 2 relations or tables. Select and project operations are called unary operations, whereas Cartesian product, union, and set difference are called binary operations. The select operation. The select operation is performed to query certain rows or tuples of a table, so it performs its action on the table horizontally. The tuples or rows are selected through this operation using a predicate or condition. This operation works on a single table and returns rows that meet the specified condition. Lower Greek letter sigma is used to denote the select operation. The predicate or condition appears as subscript to sigma. In this example, sigma C1 into R, C1 is the predicate or condition. The argument relation R is given in parentheses following the sigma. As a result of this operation, a new table is formed in memory, but the original table remains intact, and all of the attributes of the resulting table are same, which means that degree of the new and old table is same. Only selected rows or tuples are picked up by the given condition. Let us see another example. Here is employee table, and we need to query all rows where salary is greater than 4,000. It is written as sigma salary greater than 4,000 into employee. This operation will produce output relation in memory with 3 rows for employees which has salary greater than 4,000. Here is another example where 2 conditions are applied. We need to fetch all employee rows where salary is greater than 4,000 and department ID is equal to 2. In this case, the select operation is nested. There are 2 sigma or select operations. The inner sigma or select operation gets all rows from employee table where department ID is equal to 2. The result produced is provided to the outer sigma operation, which selects all rows where salary greater than 4000. In other words, the inner select operation is performed on the employee table, whereas the outer operation is performed on the resultant relation, which is produced by the inner select operation. Select operation is commutative. It means it does not matter which condition is applied first. However, I have written a second equation which produces the same result as the first one. The inner select operation selects rows from employee table where salary is greater than 4000. The resultant relation is provided to the outer sigma or select operation. The outer sigma or select operation gets all rows where department ID is equal to 2. Both of these equations produce the same result. Most often, we need to query a subset of columns of a table or relation. This is done through project operation. It is denoted by pi symbol, comma separated names of attributes or columns are mentioned as subscript of pi. SQL select statement is used to query data from relational databases. Select statement has many clauses. These have different purposes. Here is the basic syntax of select statement. Every query starts with the select keyword. After the select keyword, we provide names of columns separated by comma. Then in the from clause, we write the names of the tables from which columns are to be fetched. Sometimes we need to fetch all columns of a table. In this case, instead of writing comma separated names of columns, we just write asterisk after the select keyword. Here are two select statements. Select empid, comma salary from employee. The output relation produced will contain empid and salary columns of the employee table. Select static from employee will produce all columns from the employee table into output relation. Let us see another important clause of select statement. It is where clause. After the where keyword, we write a condition. For example, select static from employee where salary greater than 4000. This query gets all records from employee table where salary is greater than 4000. Where clause is optional. Here is another example of nested SQL statement. The purpose of this query is to get all rows from employee table where DPT ID is equal to 2 and salary is greater than 4000. Please note that the inner SQL statement select asterisk from employee where DPT ID is equal to 2. It is enclosed in braces. It executes first and gets all rows from employee table where DPT ID is equal to 2. Result of the inner SQL is produced in memory by DBMS and is provided to the outer SQL statement. The outer SQL statement operates on it and gets the rows where salary is greater than 4000. The inner SQL statement is most often known as subquery. In this case, instead of providing table name in the from clause of the outer query, we have provided a subquery. This concept is important to understand. Here is a simplified form of the last query. Select asterisk from employee where salary greater than 4000 and DPT ID is equal to 2. In this case, two conditions are mentioned in where clause using AND keyword. AND keyword is known as logical operator. Logical operators are used to specify compound or complex conditions. There are three logical operators. These are AND, OR, and NOT. Here is a list of comparison operators which can be used in conditions. These are equal, less than equal to, greater than equal to, and not equal to. So far we have seen projection and selection operations. Then we translated these operations in select statement. Let us understand Cartesian product. This operation is very important to understand. Cartesian product or cross join is binary operation. It means it operates on two tables. It returns rows by joining two tables of different degrees. Both of the tables can have different number of columns and different number of rows. It is denoted by cross. If R and S are two tables or relations, then their cross join RxS will contain the attributes of R and all the attributes of S. Moreover, all the rows of R will be merged with all the rows of S. Total number of rows in the resulting relation will be total number of rows in R multiplied by total number of rows in S. It is also known as cross product. Here is an example of Cartesian product or cross join. There are two tables, customer and employee, and customer cross employee is the output table produced. Customer table contains 5 columns and employee table contains 2 columns. So the total number of columns in the result table is 5. Number of rows in the customer table is 2 and the number of rows in the employee table is 2. Total number of rows in the result table is 4, which is 2 multiplied by 2. Let us see how cross join is performed. First of all, first row from the customer table is picked and first row from the employee table is picked, and these are joined together to produce the first row in the result table. Then the second row from the customer table and first row from the employee table is picked and joined to produce second row in the result table. Then the first row from the customer table and second row from the employee table is picked and joined to produce the third row in the result table. Finally, second row from the customer table and second row from the employee table is picked and joined to produce third row in the result table. Now let us have a look at SQL statement which is written for cross join. Select customer ID, name, customer.employee ID, employee.employee ID, employee name from customer, cross join employee. Please note the cross join clause of the select statement. Name of the first table, which is customer table, is mentioned in the from clause, whereas name of the second table, which is employee table, is mentioned in the cross join clause. You cannot mention names of both tables in from clause. Another thing worth noting is the name of the employee ID column. In SQL statements, we cannot include two columns with the same name. If we do, we must prefix it with the table name followed by a dot. So instead of writing only employee ID, I have written customer.employee ID and employee.employee ID. Now let us examine the result of cross join between customer and employee tables. There are two columns with the names of employee ID. In the first row, first employee ID column has value of null, whereas second employee ID has a value of 1. This is misleading. The fact is that we have not assigned any employee ID to customer 101 in the customer table. In the second row, both of the employee ID column contains 1 as their value. It means this is correct information. In customer table, we have assigned employee ID as 1 to customer 102. Similarly, third row and fourth row are also producing wrong information. Their employee ID fields contain different values. So out of 4 rows, only one row is producing the correct information. These are the rows which contain same value in both of the employee ID columns. Another problem with the cross join is that it produces huge number of rows when the source tables contain millions of rows. It is very costly operation and many database management systems do not support it. Let us see inner join. Inner join is based on the Cartesian product or cross join, but it returns only related rows between two tables based on a join condition or predicate. Most often, the join condition is between primary key columns of one table to the foreign key columns of the second table. Here is an example of inner join between customer and employee table. The join condition is customer.customer ID is equal to employee.employee ID. Here is SQL statement for inner join. Select customer ID, name, customer.employee ID, employee.employee ID, employee name from customer, inner join employee on customer.employee ID is equal to employee.employee ID. Please note that the first table's name is specified in from clause, whereas name of the second table is specified in inner join clause. Join condition is mentioned using on clause. So when inner join is used, join condition must be provided using on clause. Please note that we cannot use where clause to specify a join condition. Another type of join is left outer join. Left outer join also gets related records like inner join. In addition, it also gets non-related records from first table. In other words, it returns all rows from the first table and only related rows from the second table. Total number of rows in the output table are equal to the total number of rows of the first table. The first table is known as left table and it is mentioned in the from clause, whereas the second table is known as right table and it is mentioned in the left join clause. In this case, customer is left table, whereas employee is right table. There are two rows in the result set. Employee ID and employee name columns for customer 101 are shown as null. This is because no employee is assigned to customer 101. This is non-related record. Second row in the output is for customer ID 102. It is a related record It has employee ID 1 assigned to it. SQL statement syntax is similar to inner join. Instead of using inner join keyword, left outer join keyword is used. Another type of join is right outer join or right join. Gets related records from two tables. In addition, it gets non-related records from right table. Name of right table is mentioned in the right join class. In other words, left outer join returns all rows from second or right side table and only related rows from the left side table. In this example, employee is right table, so all the rows from employee table are returned and only related rows from customer tables are returned. Full join or full outer join. This is another type of join. Full outer join gets related rows between two tables. In addition, it gets non-related rows from both the tables. Full join clause is used with joining condition. Let us summarize the joins. Joins are based on Cartesian product or cross join. Cross join produces some undesired or misleading rows in the output. It is also costly operation. To produce desired output, we often need to use joins which query data based on a join condition. Inner join produces only related rows in the output based on join condition. Outer joins allow to get unrelated records in addition to related records. There are three types of outer joins. Left outer join. Left outer join gets non-related rows from the first table in addition to related rows from both the tables. Right outer join gets non-related rows from the second table in addition to the related records from both the tables. Full outer join gets non-related rows from both the tables in addition to related records from both the tables. Order by clause is used to sort the output relation in ascending or descending order. Ascending is the default sort order, but you can explicitly mention ascending or descending order. Here is an example of order by clause. Select asterisk from customer order by name. Because ascending is the default sort order, it sorts the rows by name in ascending order. Here is the same query as previous one with the same output, but note ASC keyword after name in the order by clause is used. Descending or DESC keyword is used to sort rows in descending order. Note the output is sorted by name in descending order. You can use more than one column names separated by commas in the order by clause and mention ascending or descending order with each column. Our next topic is union operation. Sometimes we need to combine or merge the output generated from two or more select statements, but the select statement must be compatible with each other. All select statements must output same number of columns and the columns should be in the same order in each select statement. The columns must also have similar data type. The columns in each select statement must also be in the same order. Here is an example of union operation. Select vendor ID, name from vendor, union. Select customer ID, name from customer. Please note, both of the select statements has different column names. Vendor ID is in the first select statement, but customer ID is in the second select statement. But both of these columns has similar data types. Therefore, these are compatible columns with each other. Now have a look at the output table, which is customer U vendor. First thing to note is that names of columns in the output table are picked from the first select statement. Second thing is that it contains only unique rows. Rows for name John only appear once. Row for name John only appear once. If you need duplicate rows in the output, you can use union all instead of union. This will produce duplicate rows in the output. Just have a look at the output. It contains two records for John. Please note the output records are not sorted. To sort the output records, order by clause is used. Order by clause is used only with the last select statement. It will sort all records. As you know, output derives its columns names from the first select statement. You can only sort on the columns which are provided in the first select statement. Set difference. Set difference returns all rows produced from the first select statement which do not exist in the output generated by the second select statement. Both of the select statements must be compatible. It means they should produce same number of columns with same data types with same order. So compatibility rules are same as we discussed in the union operator. In SQL Server, except keyword is used for difference, whereas in Oracle, minus keyword is used. This part of SQL tutorial ends here. Please subscribe to my channel. I am going to produce some good tutorials based on your feedback. Please write your comments or ask questions in the comment section. And also share with your friends. Thanks in advance.